Okay. Mr. Zoom user Bunton, guys, can you hear me? Samna,
Yeah, I hear you well.
Yes.
is my voice clear?
Super clear.
Okay, guys, very good. Actually, if it is clear, we can start. All right. Usually we will start at around 5:10 or 5:15. So you need to expect a link from me at around 5:10 or 5:15. Because right before this class, you may have class or not. Anyway, online class, I'm not going to teach you like for 50 minutes. Just we are going to have class for about 35 or 14 minutes. Okay. So that you'll not get bored. And so guys, let's continue then. As you know, actually, uh, we were talking about chapter 1 functions. In the classroom, we talk about functions and the graphs and types of functions. And now here we will continue this. Okay, the second part of the chapter is about combining functions, shifting and scaling graphs. So we're going to get introduced with two concepts here. When we just say combine, actually, if you're given two functions, for example, how do we combine these functions? Usually we can combine these two functions using some algebraic operations, right? We have four arithmetic operations, as you know, like we can add two functions, we can subtract one function from another function, or we can multiply one function by another function, or we can divide a function by another function. Okay. 1.3 is trigonometric function that hopefully we will talk about 1.3 in the classroom. Okay. So what we have here, we have sums and differences, products and quotients. Actually, these things are not very new for you. We have already started here. And one more time, you are going to just see this from, I don't know, in a more general settings, okay? And after that, we have composite functions and shifting a graph of a function, scaling and reflecting a graph of a function, ellipse. Anyway, these are the things that we are going to study through this during this class. So now let's talk about sums, differences, products, and quotients, right? Okay, here we are talking about two functions. Let's say the first one is f, the second one is g. What's going on here? Okay, and by suppose that this x, okay, our input value function, it is taken from the intersection of domain of f and domain of g. Then we define functions f plus g here and f minus g here. F is multiplied by g here. F is divided by g here. Okay. And you must have studied this in grade 10 or maybe 11, how to add two algebraic expressions or how to subtract one algebraic expression from another algebraic fraction, right? The idea is very simple, right? Uh, we should just using some algebraic properties, right? We should just expand or add or subtract. That's it. So number one, f plus g of x. What do we mean by this? We mean that we are just adding two functions together, right? For example, simply here we have f of x. Let's say it's a quadratic function, x squared. And we have another function here, g of x. Let's say it is 2x minus 1, right? So we know that what is the domain of f here? Domain of f is the whole and entire real number, right? That is R, because every function can be its domain. And how about the domain of g function? And also just a linear function. It's a polynomial function. And usually we know that the domain of a polynomial function is the entire real number line. So also it is R, right? And also here, what is the intersection of this R and R is just R. Then that means that here by adding this, right, f of x plus g of x, now we are producing new function, right? That means that we are just combining these two functions by addition. So what is it? It's just x squared plus 2x minus 1, right? Now we got another quadratic function adding these two functions. Now what is the domain of this function? The domain of this function is how can I just admit everybody? Because they're just participating one by one. Anyway, let me change the color here to purple. Purple is much better. And how about if we multiply or subtract, for example, f minus g of x, right? So that is, again, here it's like we have algebra expression in x, and also here we have algebra expression in x, right? We're just subtracting 2x minus 1 from x squared. So here we have x squared minus 2x plus 1. And also in this way we can multiply this. How about here we have fg of x, right? So that is x squared times 2x minus 1. Anyway, so in this way, actually, we can combine two functions by adding two functions, by subtracting a function from another function. And here, make sure that when we just compose or when we just combine this function in this way, their domain will be the intersection of their domains. Now we will see them in this example. The functions defined by the following formulas. F of x is equal to square root of x, and g of x is equal to square root of 1 minus x are given. Complete the following for a table. Okay, so immediately from here, we know that what is the domain of f? Domain of f is, what is it? Just all the numbers that's not negative, right? That is here, x is greater than or equal to 0. And how about domain of g? Domain of g is 1 minus x. So 1 minus x should be greater than or equal to 0. That means that x is less than or equal to 1, right? So these are the domain. Now, if you just find the intersection, x is greater than or equal to 0, and x is less than or equal to 1. And what is the intersection of these two intervals? The intersection will be, that is a domain, right, of f intersection domain of g, that is just from 0 to 1. Okay, so now we are considering there is sum, there is a difference, and blah, 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 and over this interval from 0. So what is f plus g? F plus g, for that the formula is square root of x plus, and here the second function is square root of 1 minus x, right? And how about the domain? Actually, this each one should be defined, right? What interval it is, the domain will be from 0 to 1. And how about f minus g? That is square root of x minus square root of 1 minus x, right? How about the domain? Again, the intersection of these two functions domains, that is from 0 to 1, right? And how about g minus f? G minus f is square root of 1 minus x minus square root of x. Again, domain is the same, 0 and 1. And how about their multiplication? The multiplication is square root of x, right, times 1 minus x. And the other same thing. And their division, here we have square root of x over square root of 1 minus x, right? So that's it. Now I can simplify this, of course. And now here again, we need to add one more condition, since actually our function involves denominator, or let's say the fraction. And also we have to consider that it is denominator should be non-zero. That means that whatever you substitute for x and evaluate that expression, which is in the denominator, it should be non-zero, or it should produce non-zero real number. So that means that then its domain will be from 0 inclusive here and 1 exclusive, not including this one. And how about g over f? G over f is square root of 1 minus x over, and here we have square root of x, right? Now from left, as you see here, if x equals 0, we will have 0 in the denominator, which actually is not, defined. So the domain of this combination of these two functions will be, what is it, from 0 not inclusive to 1. It is inclusive because in the numerator we can have 1. Mr. Mesa, is everything all right?
Yes, sir.
Yes.
Good. Guys, if you have any question, you can ask now. If you are shy, you just put a question mark and we can discuss more. But what we are studying here is very, very basic, fundamental things. And this is just the graphical representation of combining these two functions. For example, let's say that f of x, that is our f function, let's say, and g of x is represented by this yellow line, for example, by adding, if two functions are positive, right, that new value right here, it will be this. That red line is the graph of the sum of these two functions. And how about here multiplication and also subtraction? In this way, we can actually describe this. But maybe here in subtraction, it may be negative. We don't know. Also multiplication, we don't know. It's just one example how we are combining this. Because at point A, right, that is a value of the function f here. Here it's a value of the function g here. And when we just add this, we will get a bit different value, right? How about if you subtract this and the difference is maybe if f minus g, that will be negative under the x-axis, right? Or g over x, it is about the x-axis also, it will be very short. I mean, the height will be quite short. Anyway, here also is about what is it, multiplication of two functions. Here in blue line, let's suppose that that is our function square root of x, and the yellow line, that is square root of 1 minus x, right? And how about over the interval from 0 to 1, right? What is the combination of these two functions? If you add them, right, just actually point wise, right? Every point you are just adding. For example, let's say, how can I draw the graph? At 0, calculate this value, right? When it is 0 is equal to 1. And after that, at 1 over 5, evaluate this. And also 2 over 5, evaluate this and add them up. And after that, we can just plot those points, like how many points we have here. As 0, 1, 1 over 5, 2 over 5, 3 over 5, 4 over 5, and 1. So here we have 6 points, right? And if you just plot this, after that, you can just see the general picture of the graph. And just joining these points with a smooth curve, we can get the graph of the function. But here, the graph of the function, what is it? How did we obtain this? By adding these two functions. Anyway, now guys, let's talk about another important operation on functions, or combination of functions. What is it? Composite function. And also we can compose two functions in another way. Now, we have just studied that we can, how to say, combine two functions by addition or subtraction, or by multiplication, or by division. But another form is if f and g are functions, the composite function f of g. Composite means simply it is a function of a function. All right, in a lot of cases you will see that functions are described as a function of function, right? For example, if you just consider here, f of x is equal to, for example, let's say it is 2x minus 1 squared, right? Now, if I just take this 2x minus 1 as u, suppose that we just introduce this label, u, or u of x, okay, is equal to 2x minus 1, right? At the time, I can write here this f of u is equal to u squared. And what is u? U is also a function of another variable, right? U is a function of x. And how about f here? F is a function of u. So also in this way, we can combine two functions. And you will see that we will use this composite function a lot in this course, or throughout this course, we will see them a lot. So anyway, now let's get back to the definition, how we are defining the composites of two functions. So if f and g are functions, the composite function, we just read it as f of g, or f composed with g, okay? And in short, you can just read it as f of g, is defined by what we mean by this notation, f, and here we have small circle here, and f of g of x, right? It's just f of g of x. So the domain of f of g consists of the numbers x in the domain of g, for which g of x lies in the domain of f. Now, as you see here, actually, what is it? So simply, you're just putting input value, right? And that input value is going through two different processes. Number one is, for example, you just put input value here, and we have one machine here, right? And what is the function of the machine? It is just doing this G operation. What is G operation? It can be a lot of things, right? Maybe multiplying the given value by 2, or first multiplying by 2 and adding 3, for example, or maybe whatever you substitute, the function's job is to square it or to cube this or anything, right? And we just call this the operation. And after that, okay, first, after actually it accomplishes function and sending again the output value to another machine, right? Here we have another machine here, actually here another machine here, and this machine is also processing this input value, and after that, it's just producing the output value here. Actually, this process is just one example. It may go through maybe 2 steps or 3 steps or 4 steps or n steps in general, okay? Now here, not in a single step. Now we are just giving example where the input value goes through 2 different processes. Anyway, 2 functions can be composed at x whenever the value of one function at x lies in the domain of the other. The composite is denoted by f of g. Let's see in some examples. So here we have the function x, right? And you're just sending to another machine. It is processing this, and we got another value here, g of x, and is sending to f. But here we can just send this also directly to the third machine, right? By what operation? This operation, f of g. Okay. An example, let's just get back to this example. For example, if you're talking about this f of x, right? That's equal to 2x minus 1 squared, right? Or also, actually, I can obtain this in this way. Here we have u is equal to 2x minus 1. And here we have f of x is equal to x squared, right? Now, if I combine these 2 functions, what we have here? Here we have, as you see here, whatever input value, this f functions, okay, let me just write here also u of x so that you don't get confused, because u is a function of x. So what is the job of function u? The function of u is actually carrying out this operation, right? Whatever you substitute into the machine, for example, it just multiplies that input value by 2 and subtracts 1 from the result, right? And how about we have the second machine? That is our first machine, that is u function. And the second machine is our f function. And since it is g, actually, I can use g here. Doesn't matter, actually. Here I have g, okay? So we are talking about this thing. All right. So what is the function? Actually, g is doing here. Whatever you substitute here, right? That is 2x minus 1. That means that it is multiplying that input value by 2. And after that, it is subtracting 1 from the result. And what is the responsibility or the job or the task of this f? F's job is whatever you actually input, right? It is just squaring. So its job is squaring the input value. So now can we do 2 things at the same time? It just means one operation. Actually, at the time, actually, what is it? Then actually we need to, how to say, make use of composite function. The direct way is, what is it? This one, right? F of x is equal to 2x minus 1 squared. Actually, these 2 jobs we're just doing together in just one process. Whatever you substitute here, and the function without going through this g and f, by just composing the 2 functions, we can reach the output value. Anyway, these are just theory. Now let's see in examples. If f of x equals square root of x and g of x is equal to x plus 1, right? Find f of g of x. So that means that, what is it we mean by this? That means that f is a function of g and g is a function of x. Now from here, f, what is g of x? G of x is given here, x plus 1. So here we have x plus 1, right? Now what is the job of function f? Whatever you substitute for x, it's just taking the square root of that input value. So here, our input here, x plus 1. So here the result is x plus 1, right? And how about question B? Question B is g of f of x, which is equal to g. What is our f function? That's equal to square root of x. And how about the function of g? Whatever you substitute here is just adding 1. So that is, here we have square root of x, that is input value, and adding 1. And how about f of x? That is f of x. So that is equal to f of our function f is square root of x. Just a second. Oh, yeah. The screen is too bright. I don't know, my eyes get so tired so quickly. Let's use our glasses for the computer screen. All right, so here f of x, here we have f of square root of x, right? And again, what is the job of function f? Whatever you substitute, right, or give an input value, it's just taking the square root of that thing. But here our input value is not x. Now here our input value is square root of x. So here we have square root of input value. What's our input value? That is square root of x. So which is, by now, algebraic manipulation or simplifying, we can get that here, fourth root of x. And how about g of x? So that is g of x, which is equal to g of, what is g of x? G of x is x plus 1, right? So now, as you see here, the input value is x plus 1. The job of, or the, what is it? The function of g is just adding 1 to the input value. So our input value is x plus 1, right? And it is just adding 1 to this input value, which is equal to x plus 2. Guys, if you have any questions, anytime you can raise your hand and ask. If you have no question, just enjoy it. I don't know where you are sitting right now. If it's at university, I don't think it's so comfortable, but if it's at home, make your coffee, put it on your table. I don't know, just watch and listen. That's it. Continue. Now, guys, let's talk about shifting a graph of a function. So we have usually in shifting 2 different shifts. We can shift the graph of the function maybe to the right or to the left, right? Or we can shift the graph of the function up or down. That's, we call this vertical shifts and the horizontal shifts. And the drawing, and this one also is, it may be a little bit, I would say, not convenience, especially on these drawing tablets. Also, I'll try to show this using the Graphmatica. That is a software that I have already mentioned in the classroom. Okay, vertical shifts. For example, our function, let's say parabola, right? If you want to shift this vertically, let's say 1 unit up or 1 unit down, what shall we do? In this case, we need to either add or subtract a constant number from the function, right? So that is by adding something to the value of y, we can shift this up or down. So y is equal to f of x plus k, right? Here, y equals f of x plus k. What we are doing here, actually also in different form, I can just write it as y minus k is equal to f of x, right? Let's say that shifts the graph of f up k units if k is positive, and shifts this down if absolute value of k units if k is negative, right? If k is negative, is shifting down, shifting down. If it is positive, shifting up. Now we will see them in examples. And horizontal shifts. And how about adding some value? Because when you talk about function, here we have 2 different variables, right? Number 1 is x, number 2 is y. Of course, it may change depending on the context. And let's just call them as, what is it? Independent variable and the dependent variable. So actually to perform or to accomplish these shifts, right, vertical or horizontal shifts, either we need to add some constant. That constant may be positive or negative. Anyway, let's say here it is k. So we need to add this k either to x, right, or to the function itself. That means a to y. So for example, all right, consider the functions f of x equals x squared and g of x equals absolute value of x. Guys, I will just show them in using Graphmatica. I will share my screen first. Okay, and here we have Graphmatica. All right, we are talking about two different functions. Y is equal to x squared. Mesa, can you see my screen if you are there, if you didn't fall asleep? So what do you see, Mesa, on the screen?
function.
What do you see? Yes, Mesa, what do you see in
The
this?
parabola.
Parabola.
What color is it?
Red and white, and is it green or black?
Okay, good. At
It's
least you
pink,
can
right?
see the parabola. Anyway, I think the color is pink, right? Okay. Anyway, guys, let's continue. So now what happens if I just add a constant to y, right? Or I can just add to the function itself. The function itself means we are adding or subtracting something from y, right? So now as you see here, if I add, for example, 2, right? So if I add 2, k is constant, that's just shifting 2 units up, right? And how about if I subtract, for example, that's our k, right? Minus k. So that means it's just pulling the function down, either pushing up or pulling down. So if we subtract 2, right, it is just shifting the function 2 units down. Okay, 2 units up and 2 units down. All right. And how about, for example, instead of this subtracting the whole constant from the whole function, if I add or subtract something from the independent variable. Now here we have only one x. If we have more x's, that you have to change every x, right? Instead of x, you need to write x plus k, right? If let's say I want to shift this 2 units to the right. If I want to actually shift the unit, the graph of the function 2 units to the right, then we have to subtract 2 from x value. So here I have x value, let me open parentheses, minus 2 and close the bracket. So that means that now I am subtracting a constant from x, right? So that means that we are shifting the graph 2 units to the right. So here we have the blue line, exactly just shifting. And I don't know if you have ever studied programming, for example, in computer, right? For example, we have a circle here. If you just shift circle to the right, but actually the interval is too slow, what do you see there? And usually in computer, how do they draw this? They just draw, delete, draw, delete, draw, delete. And each time when they are redrawing the picture, they are just shifting the circle, it's some small unit to the right. And when this process happens very fast, actually, I don't know, it's a kind of illusion or something, whatever you call this, you just see that the circle is moving to the right, right? Actually, it's not moving. You're just deleting and redrawing it. Anyway, how about if I add 2, for example, to the function? Let's say, what happens here? Adding some value to the independent variable. That means that we are just shifting the whole function that here, for in this case, 2 units to the left, right? So if I just do this, and we are just shifting this 2 units to the left, okay? That's all about shifting to the left, shifting to the right. And now let's talk about scaling. Let's get back to our thing. Scaling. To scale the graph of a function y is equal to f of x is to stretch or compress it vertically or horizontally, right? One very good example to understand this one is, for example, if we are given a circle, right? If you just compress this vertically, it becomes an ellipse, right? If you just compress this, for example, horizontally, again, it becomes a ellipse, but this time it's a bit, what is it, long. Number one is just smashed, or the second one is smashed from left and right hand side. Anyway, okay, guys, just 5-6 minutes. I will finish this class. How many slides? 1, 2, 3, 4, 5, 6. Okay, let's just finish this. So, scaling, reflecting a graph of a function. For c is greater than 1. Okay, in general, so we can just take as any number, but if we know that c is greater than 1 or between 0 and 1, I can see it is stretching or compressing. Anyway, so y is equal to c times f of x. What happens if I multiply the whole function by c? Actually, the effect of this multiplication is it stretches the graph of f vertically by a factor of c, right? Stretch means that our function gets longer now. And how about multiplying by 1 over c? Since c is greater than 1, 1 over c is less than 1 and greater than 0. As that compresses the graph of f vertically by a factor of c. In this way, how about if you multiply independent variable by c and divide by c? The first one compress the graph of f horizontally by a factor of c, and the second one is stretch the graph of f horizontally by a factor of c. To actually understand this well, guys, you need to just do this on a circle, okay? For example, if I take the circle, for example, let's just do this, okay? And after that, I will finish the class. This is the last example. And let me just draw a graph of a circle. For example, x squared plus y squared is equal to, let's say, the center, the radius is 2. That is our circle, okay? So in the formula, maybe if you're keeping the paper on your table or not, you can look a bit later. So what happens if I just change, for example, let's start with y, okay? I am going to multiply y here, the first one, we're just testing the first one. Here, multiplying y equals c times f of x. It says that stretch the graph of f vertically by a factor of c, right? So the function becomes actually here a bit, what is it? From the bottom and from the top, you're just stretching, right? Here, let me just put here instead of y, let's multiply by 2, okay? So what will be the new graph of this function? Okay, see here, c is greater than 1, right? And multiplying the whole thing by 2. So here, just a minute. Stretch the graph of f vertically by a factor of c. Okay, so here, actually, all right. Guys, just I want to give one thing here because you may get confused here. Okay, here, this y is equal to c times f of x, right? And here c is greater than 1. It is the same thing as multiplying y in the function by 1 over c. That's equal to f of x. But in our case, how about in the second one? In the second one here, for example, okay, here y is equal to 1 over c times f of x. F is our original function. And if you just take this c to the right-hand side, here we have multiplying c by y, and here we have f of x, right? So in the first case, we are multiplying y by 1 over c. So that is a stretch, vertical stretch. And the second one is multiplying C, I mean, the whole function by C. That is the compression, right? The vertical compression. So that's why in this graph here, you see, okay, you see, for example, the blue line, I have multiplied the Y value by 2. Now our graph is compressed, right? So instead of 1/2, how about if I multiply 1/2? 1/2 is 0.5. Now you will see that we are just stretching the graph by a scale factor of 2, right? In similar way, how about if you just change this x, for example, let's say by 3, okay, by 3, it is compression, right? This 3 times x, we are just compressing this. And if you multiply x by some value that is between 0 and 1, that we're just stretching along the y-axis. Anyway, guys, thanks very much for joining this class. And that's all about shifting. And the things are really not so hard. What I suggest you is some questions you have to do them manually. And also this Graphmatica, just check this how the things are changing, okay? And after practicing a few questions, you will see that these are not so difficult things. And that much information is enough, okay, for you about the scaling and shifting, okay? Guys, have a good
Professor.
night and have a nice evening. I will meet you on Wednesday, okay? Enjoy your dinner. See you. Bye-bye.
Bye-bye, sir.
All right, thank you.
Bye.
Goodbye.
Okay.